Welcome to the video guide for installing and starting up the ACS880 Enduradrive Fan System. This video is intended as a step-by-step review only for technicians who have completed formal training on the installation and startup of the Enduradrive 880. The information in this video corresponds with the Enduradrive ACS880 startup guide and is divided into 4 sections: installation, setup, testing, troubleshooting. This section will cover how to correctly install your Enduradrive ACS880 fan system control, including wiring the motor thermostat, setting the vibration switch, setting the building management system start-stop command, the run command, and the optional de-ice command. These instructions correspond to step 1 through 3 of the Enduradrive ACS880 startup guide. The first step in setting up the Enduradrive ACS880 is ensuring proper wire connections are in place. Before you begin, it's critical that you ensure to lock out power. The permanent magnet motor generates potentially dangerous voltage whenever it spins. So for safety purposes, you must first isolate both incoming and outgoing power prior to exposing wiring. Always make sure you lock out the VFD power upstream of the device before exposing or altering any wiring. Once you ensure the power is safely locked out, it's time to gather the information you'll need to set proper wiring. First, find the warning label on the Enduradrive motor. You'll need the EMF voltage number stamped on the label. Write down the EMF number on a piece of paper. We recommend also taking a picture of the label for later reference during the setup process. Next, locate the nameplate on the Enduradrive motor. Once again, write down the information you'll need during the setup and take a picture of the nameplate for later reference. You will need to write down the horsepower, the RPM, the amps, the volts, and the hertz. Once you've gathered the necessary information from the motor's warning label and nameplate, it's time to ensure the wiring connections on your motor match the wiring diagram. You should have a copy of the wiring diagram for your unit in the packet that came with the unit. Thermostat wiring at the motor and at the VFD. Let's start by ensuring the motor thermostat is correctly wired. This is important. If you attempt to run the motor with incorrect thermostat wiring, the motor warranty will be void. Ensure the motor thermostat wires are correctly installed. The thermostat wires are the two small identical wires coming from the motor. They should be connected to field wiring running inside its own separate conduit. If these wires are not connected, stop and consult with the installing electrician. Once you're sure the thermostat wires are connected at the motor, let's ensure they are connected at the VFD. Either one of the two wires needs to be connected to the terminal labeled XD24-1 and the other wire connected to the terminal labeled XD24-2. If the thermostat is not correctly wired, there will be a warning message on the display that reads Thermostat Interlock. Vibration switch wiring. Now that we are sure the thermostat is correctly wired, let's do the same for the optional vibration switch. If you do not have the optional vibration switch, skip this step. If you are using a tower vibration switch, make sure it is correctly wired to the VFD terminals. The vibration switch wires should be connected to XDI6, which is labeled DI6, and XD24-4, which you see labeled plus 24VD as pictured here. If the vibration switch is not correctly wired, there will be a fault message on the display that reads Vibration Switch. If you are not using a tower vibration switch, you will need to insert a jumper wire between VFD terminals XDI6, labeled as DI6, and XD24-4, labeled as 24VD. BMS wiring. Now that you have confirmed proper wiring of the optional vibration switch, it's time to check the BMS wiring. Depending on your BMS system, your speed command will be either 0 to 10 volt signal or 4 to 20 milliamp signal. Wiring the BMS speed signal. Wire the building management system speed signal to VFD terminals XAI4 and XAI5. XAI4 is positive, XAI5 is negative. If you determine that you need to change from a default to 0 to 10 volts, you will need to change the J1 jumper setting. Refer to the motor wiring diagram in the BAC submittal. To change the setting, you will have to move the J1 jumper and change VFD parameter 12.15. After completing the wiring for the BMS speed signal, let's ensure the BMS wiring for the BMS start-stop or run command is complete. You will need to install either a 2-wire or 3-wire start-stop signal. To install the 2-wire BMS start-stop, wire the leads to terminal XD24-4 and XDI-1. Note, close equals start and open equals stop. XD24-4 is labeled as plus 24 volts, and XDI1 is labeled as DI1. For 3-wire start-stop configuration, see the ACS880 user guide. Now, let's review wiring in the optional BMS de-ice command. You may or may not have this feature. To install the BMS de-ice command, land the leads on terminals XD24-4 and XDIO-2. XD24-4 is labeled as 24 volts, and XDIO-2 is labeled as DIO2. Remember, closed equals de-iced. In this mode, the motor runs backwards. Open equals no de-icing. If the BMS de-ice command is not required, do not land any wire on XDIO-2. If you want more detail on correct wiring, see the ACS880 plus N5350 Cooling Tower Drives User's Guide. Step 2. Setup. This section will cover how to correctly set up your Enduradrive Fan System VFD. The ACS880 VFD firmware walks you through basic questions for setting up the cooling tower. The review provided here corresponds to steps 4 and 5 of the Enduradrive ACS880 Startup Guide. On initial startup, the VFD asks for a language selection. If you do not see this, navigate to it by pressing Menu, then Assistance, press Select at Motor Data and ID Run. At Motor Setup, press Next. Then press Next again at Start Setup. With the language option now on display, choose the appropriate language. Here we've selected English. Press Next. Next, ensure the word Local appears on the screen. If the word Local does not appear, press Local Remote or LocRem button to get Local on screen. Once that is done, press the red Stop button. Now we're going to set the date and time. Continuing in the Start Setup mode, press the right arrow button on the keypad to adjust to the current date. Then press the right Soft button to save the date. Using the down arrow, scroll down to Timeline, then press the right arrow button on the keypad to adjust to the current time. Once the proper time is set, press the right Soft button to save the time. Press Next. Now that the date and time are properly set, the VFD will have us set the units of measurement on the display. You could choose either US Standard, Imperial, or International Metric units. Once you've highlighted the proper choice, press Next. Leave Unit Selection, Tariff Currency Unit, and A1 unit selection at the default values. Press Next. Now the ACS880 will have us set up the supply voltage. If you have a 208 volts or 240 volts power system, select option 1, which displays 208 to 240 volts. For 460 volts or 480 volts power systems, select option 4, which displays 500 volts. If you have a 575 volts power system, select option 5, which displays 525 to 600 volts. The display will only show the option your drive is rated for. In this example, the system is rated for 208 to 240 volts. Make that selection. After selecting the correct supply voltage, press Save. Then press Next. Set up motor data. Once the supply voltage is set, the VFD will prompt us to set the motor data. In this section, it is important that you ensure the previous settings are saved correctly before proceeding. Before starting, find the photo of the warning label and the EMF value you recorded earlier. Also, find the photo of the nameplate and the nameplate values that you recorded earlier. Remember to use the values on the setup line. Ensuring the display is in motor data mode, leave the motor type on the PM-SM selection and press the down arrow. Now, let's enter the back EMF voltage. Enter the open circuit voltage value you recorded from the warning nameplate to the nearest tenth by using the up and down arrows to change the values. Press Save. Once the back EMF voltage has been saved, you will be prompted to set the nominal current for the motor. Locate the data for amps on the nameplate and enter the number to the nearest tenth into the display. It will be printed on the nameplate as amp. Remember to use the value from the setup line and not the cont line. Then press Save. Next, let's set up the nominal frequency for the motor. Locate the data for hertz on the nameplate and enter the number to the nearest tenth into the display. It will be printed on the nameplate as Hz. Remember again to use the value from the setup line, not the cont line. Once the data is entered, press Save. Now, let's set up the nominal speed for the motor. Enter the speed. It is the number on the nameplate printed as RPM. Remember to use the value from the setup line. Once the number is entered, press Save. Next, set up the motor horsepower. Enter the horsepower printed on the nameplate as HP. Again, be sure you're taking the value on the setup line and round it off to the nearest hundredth. Once entered, press Save. Then press Next. Now, let's view the auto phasing. This is the automatic routine that lines up the motor magnets to the electrical motor poles. This happens on every start signal. Leave the default values at 50% and 15 seconds. These values can be adjusted later if you experience cogging. Press Next. Now, let's set up the motor ID run. First, check to ensure you are in mode for ID run. Before we begin, we need to make sure the tower disconnect is closed and the motor is connected electrically to the VFD. Now, reconfirm that you are in ID run mode. Scroll to highlight Standstill ID Run. You can select None only if you are running through the setup for a second time. Press Next. Once the ID run mode is set, we need to run the ID routine. Press the green Start button on the keypad. Wait for the VFD to complete the ID run. This can take a couple of minutes, and the fan shaft may rotate up to half of a revolution. When the ID run is complete, the display will briefly exhibit the message ID run done. When you see this message, the VFD will automatically proceed to the direction test. But if you see the message check the motor parameters, then the ID run failed. An ID run fail may be caused by entering incorrect motor information. Check to make sure the motor data information you entered is accurate. If you get a red light fault that says output phase loss, this typically happens if the motor is not connected to the VFD or the tower disconnect is open. Ensure the lockout tagout is removed and that the motor cable is connected at the VFD. After you fixed the issue that failed the ID run, you must reinitialize and repeat the ID run. You could proceed to the next step when the display exhibits the message ID run done. Setup fan direction. When the ID run is completed successfully, you will need to check that the fan blades are clear from obstruction. Once this is confirmed, it's time to test the fan to ensure it's spinning in the right direction. To initiate the direction test, select the Yes Test Now option shown on the screen and press Next. Careful here to only press Next one time. Now, press the green Start button. On this command, the motor will begin a 15-second auto phase routine. This will be followed by the motor beginning to spin at 50 RPM. Have an assistant check the fan direction from outside the tower looking through the access door. He or she will need to look up and observe the direction of the fan rotation. The blade should be rotating in a counterclockwise direction and the air should be moving up. If the fan is not turning in the right direction, do not attempt to manually fix this by swapping wire phases. By following the next steps, the unit automatically adjusts the direction inside the VFD. If the fan is not turning in the correct direction, scroll to select No Fixed Direction shown on the display. Then press Next. Repeat the direction test. Press the down arrow to select Yes Test Now. Then press the Next button. Press the green Start button. Then have the assistant check to confirm that fan blades are now turning in the proper direction. If the motor is not turning at all, or if the motor cogs back and forth, you will need to adjust the auto phasing on the direction test screen. This is the automatic routine that lines up the motor magnets to the electric motor poles. The routine is automatically performed on every start signal. If you need to adjust the auto phasing, scroll to Auto Phasing menu and increase the auto phase time to 20 seconds. Then press Save. Then press Next. Choose None on ID Run. Press Next. Then repeat the direction test. If the motor is turning and is not cogging, proceed to the next step. If the motor is still cogging or not turning at all, continue to increase time in 5-second intervals and rerun the direction test until the motor is running properly. Do not exceed 1 minute. Once the fan is running properly and spinning in the correct direction, highlight the message, "Yes, motor is running forward," and then press Next. Cooling tower parameter setup. Now, let's set up the cooling tower parameters in the VFD. From the Assistance display, scroll down to where it reads Cooling Tower Setup. Then press Select. At the Cooling Tower Setup screen, press Continue. You will now see the option that reads Start Setup. Select this option and press Next. Use the right arrow, select the language you prefer to use, and then press Next. Confirm the date and time are correct. Press Next. Now let's set up the motor speed and torque limits. You should now see the limits display. Use the right arrow to change the minimum motor speed. Set the value to 0 for no minimum speed or enter the value desired. The VFD automatically sets the maximum speed value to the nameplate speed. Set this default value or enter the value desired. Do not exceed speed on the nameplate shown in RPM. Do not change the minimum torque. The value should be -50%. Do not change maximum torque. The value should be 110%. Next, let's set the acceleration and deceleration times. A longer acceleration time means slower ramping up. Shorter time means faster acceleration. If the motor is less than 75 horsepower, the acceleration time should be more than 60 seconds. If the motor is more than 75 horsepower, the acceleration time should be more than 120 seconds. As with acceleration, a longer deceleration time means slower ramping down, and a shorter time means faster deceleration. If the motor is less than 75 horsepower, the deceleration time should be more than 60 seconds. If the motor is more than 75 horsepower, the deceleration time should be more than 120 seconds. When values for both acceleration and deceleration are entered, press Next. Now, let's name the VFD. The VFD name will appear on the main screen. This allows you to differentiate between towers. For example, name the VFD as CT2. Once you've named the tower, press Next. Now that you've named the VFD, it's time to set up the VFD parameters that correspond to the control wiring. Before proceeding, it's important that you first ensure the VFD is stopped and in local mode. The display now prompts us to choose between either a 2-wire or 3-wire BMS start-stop command. Typical HVAC applications will be 2-wire, while industrial applications will be 3-wire. The 2-wire BMS start-stop command has leads to terminals XD24-4 and XDI-1. The 3-wire BMS start-stop command has leads to terminals XD24-4, XDI-1 and XDI-2. For PID or field bus setup, see the ACS880 Cooling Tower Drive User's Guide. Select the wiring configuration that corresponds to your BMS start-stop command. Select Save, then press Next. Now, use the right arrow to enable trickle current. Remember that if the trickle current is not properly configured, the motor warranty is not valid. Let's configure the trickle current power. The trickle current provides a small amount of power to the motor windings when not running. This prevents condensation from forming inside the motor. The power setting of the trickle current is based on motor frame size. To determine your motor frame size, refer to the value found in the section of the nameplate labeled FR. Select the proper wattage based on the motor frame size using the table in the user guide or the chart shown here. The wattage ranges from 75 to 400. For example, if the value in the FR section of the motor nameplate reads FL3203Y, that would correspond to FL320 on the chart, and your corresponding wattage would be 125. Match the first four characters of the frame size on the nameplate to the chart. Change the trickle power to match the frame size of your Enduradrive motor and then press Save. Now, select the delay in starting the trickle current after the motor stops. The trickle current will begin after the motor stops plus the delay time. The default value is 1 minute. Once the delay time is entered, press Save. Then press Next. Now, let's configure the optional de-icing operation. De-ice runs the motor in reverse at a slow speed to prevent ice buildup. For information on operating the equipment in cold weather, see the BAC Product Operation and Maintenance Manual. The optional BMS de-icing command has leads to terminal XD24-4 and XDIO-2. De-ice is triggered by a closed contact call from the BMS on digital input 2, wired at XDIO-2. If no wires are landed on DIO-2, de-icing will not occur. If the optional BMS de-icing command is installed, change the de-ice selection field to DIO-2. Then press Save. The de-ice speed and runtime can be adjusted to your preference within the guidelines specified in the O&M. Note: tower must be observed during de-ice mode to avoid injury or equipment damage. Caution: in de-ice mode, it is not recommended to operate the fan at speeds greater than 30%. It is important to observe the tower operation during de-ice mode to ensure that water is not being blown out of the tower through the air inlets. If water is observed blowing out of the air inlets, reduce the de-ice fan speed until no water is observed leaving through the air inlets. Confirm value of 30%, as noted above, or 35%, as shown on video. Also note: operate in de-ice mode no more than the time necessary to remove ice from the air inlets of the tower. Uncontrolled de-ice operation for longer periods of time could result in ice buildup on the fan blades due to condensed water on the blades coming into contact with cold ambient air. This could result in fan imbalance. Ensure the minimum torque setting is negative. The minimum torque default is minus 50% because the fan will be rotating backwards. Once this data is entered, press Next. Before completing the cooling tower setup, use the screen to copy the VFD parameters to the keypad as a backup. To do this, scroll to the backup option and press Next. The display will show an activity bar highlighting the backup in progress. When the bar indicates that backup is complete, the display will show the message "Backup Complete." When you see this message, press Done. Now press the back button once and the exit button once to return to the main screen. You have now completed the cooling tower parameter setup. With setup complete, it's time to test your Enduradrive fan system and VFD. It corresponds to steps 6 and 7 of the Enduradrive ACS880 startup guide. Before testing, verify that the fan system is clear of all personnel and tools so that motor rotation will not cause injury or equipment damage. During testing, have someone stand by outside the tower to make sure nobody enters the tower during this process. Remove any devices which may have been previously installed to prevent fan rotation to eliminate shock hazard, and make sure that the fan is free to rotate without contacting any obstructions, including the fan cowl. To begin, let's test the system with the VFD and local control. Ensure the word Local appears on the screen. If the screen says Remote, press the Loc Rem button. The VFD is in local mode only if Local appears on the screen. The Start button starts the fan. The Stop button stops the fan. In local mode, increase fan speed by pressing up arrow and decrease fan speed by pressing down arrow. Press the Start button. The motor should auto-phase. The default value is 15 seconds but can be configured for longer or shorter ramp-up. Using the up arrow, increase the fan speed to 100%. Check that the amps at full speed do not exceed the nameplate amps. Now press Stop. Now let's test the system with the BMS in control or auto mode, which requires the VFD to be in remote. To start, we must first switch to auto mode. To do this, press the Loc Rem button on the display. The word Remote should now appear on the screen. The VFD is in auto mode if Remote appears on the screen. Have the BMS system send a start signal. Confirm that the VFD starts. Confirm that the motor auto-phases. Confirm that the fan turns. Now, let's test the trickle current. Have the BMS send a stop signal and confirm the fan stops. Now ensure the trickle current activates. To do this, first wait for the trickle current delay to end. Then record the amps on the display. Confirm that the direction arrow is not rotating and that it is flashing. The trickle current only activates with a remote stop command. Trickle current will not activate in local mode. Also, trickle current will not activate if VFD is stopped in local mode, then changed to auto mode. To activate trickle current if there is no BMS, use the following procedure. Press the Loc Rem option on the display to switch to local mode. Press the green Start button and wait for the arrow to start rotating. Press the Loc Rem button to switch to remote. Wait for the trickle current delay time and then ensure trickle current activates. Finally, let's confirm that the speed signals are scaling correctly. To do this, have the control send a start command and then a 25% speed signal. Confirm the fan speed is now running at 25%. Next, have the control send a 50% fan speed signal, then a 100% fan speed signal. Confirm that the fan speed is correct for each speed signal sent. Troubleshooting. Now, let's review 4 common startup problems and review troubleshooting to solve them. The VFD keypad LED gives a quick visual of whether or not the VFD is ready to run. A solid green LED is needed to properly operate under all situations. A flashing green LED indicates an active warning. This may still allow operation but may need to be remedied before commissioning is complete. A solid red LED indicates an active fault. This prevents the VFD operation in all modes until the problem is remedied. You could view all active warnings and faults from the main screen by pressing the Options button, then scrolling down to Active Faults or Active Warnings. If the condition causing the fault has been corrected, the red LED fault can be reset by pressing the Reset button. The AI parameterization error occurs when your dip switch jumpers J1 and J2 do not match the programming in the VFD for AI1 and AI2 settings. This error warns you that the jumper J1 and the parameter 12.15 currently do not match each other, or that jumper J2 and parameter 12.25 do not match each other. Another common error occurs when the setting for analog input 1 is mismatched. Most of the time, analog input 1 is connected to the BMS speed signal. When jumper 1 is connected to the top two pins for a 4 to 20 milliamp speed, the parameter 12.15 will also need to be set to milliamps to avoid error. Conversely, for a 0 to 10 volt signal, jumper 1 is connected to the bottom two pins, and parameter 12.15 needs to be set to volts to avoid the error. The motor has built-in thermostat switches that will prevent operation if the motor gets too hot. You will see the warning thermostat interlock if the motor gets too hot. You will also get the same thermostat interlock warning if the wires from the motor to the thermostat are not correctly landed on the VFD. In either case, operation of the motor is not possible while this warning is active. Once the motor cools down, VFD terminal XD24-1, labeled as DIIL, and terminal XD24-2, labeled as plus 24D, will close and the alarm will clear automatically. Ensure that these wires are correctly attached. Note, if this alarm occurs intermittently, confirm the thermostat wires are not in the same conduit as the motor power wires. If the vibration switch at the tower opens, the display will show a vibration switch fault message and a red LED light will appear. Warning: rotating equipment will cause severe personal injury or death to persons who come in contact with it. Do not perform any service, maintenance, or inspection on or near the fans, motors, and drives, or inside the unit without first ensuring that the fan and the pump motors are disconnected, locked out, and tagged out. To fix the vibration switch error, first manually reset the vibration switch at the tower. Then manually clear the fault at the VFD by pressing Reset on the VFD keypad. This should return the system to operation mode. If the fault cannot be reset, check the vibration switch wires XDI-6, labeled DI6, and XD24-4, labeled plus 24V. Ensure they are closed. Sometimes someone has pressed too many buttons before you, and you want to reset the VFD back to factory defaults. To reset the VFD parameters back to the default settings, you will need to change parameter 96.04 macro select to a value of CTDD and then press Save. Warning: resetting the VFD parameters back to the default settings will undo all of the settings outlined above except for the motor data and serial communication data. These two will not be reset. All other changes will be lost. This completes our tutorial for installing, setting up, testing, and troubleshooting the ACS880 Enduradrive fan system. For more details, refer to your Enduradrive ACS880 startup guide.